Hello guys, this is our second lesson for AS level physics. Uh, so we are looking at this subchapter, that is errors and uncertainties, but they look to be the same but they are actually different, because errors are like mistakes that we do, because an error is a mistake that has been done. But obviously in measurements we do not make mistakes. No, in measurements we just have a doubt about the measured value, so meaning there's a range within which our value lies, and that is what we call uncertainty. So uncertainty is like a range of values within which our value lies, or precisely it can be defined according to an instrument. Uncertainty is the equivalence of one smallest division of an instrument, or you can say that is the smallest value possible that an instrument can read. Like that's the reading, the smallest reading of an instrument. So meaning sometimes choosing the right instrument is also a skill that we need in physics, because we do experiments. That's part of our examination. That is called the practical skills. So like for example, if we want to measure the diameter of a steel sphere, we need that appropriate instrument that is not a meter rule, that is not a vernier caliper, but a micrometer screw gauge. Why? Because a micrometer screw gauge, if you look at this, is the one that we use to determine smaller values of measurements. Like first check this metal sphere in between the jaws A and B here. If you look at it, it is so small that actually how can you use even a meter rule to determine the you can I was going to say how can you use a meter rule to determine the diameter of a ball of a circular object, just to determine the diameter. It is weird, and scientifically sometimes when we are measuring parameters, we need to know the number of significant figures that we need for that measured value, that measurement. Like if it length, for that length that is being measured. Like for example, for this one, the diameter of a steel ball, obviously it is so small, and it is better we will read the value to 2 dps, 2 decimal places, and a meter rule reads to the nearest millimeter to 0 dp, a micrometer screw gauge to 1 dp, or you can say to the nearest tenth of a millimeter. So which means the right instrument is our micrometer screw gauge, just like that. Why? Because it can read it to the nearest 1/100th of a millimeter, or obviously 2 dps, like that. And do we know how to use a micrometer screw gauge? The answer is yes. A micrometer screw gauge has two scales. We have this one that is called the main scale. We also have this one that's called a thimble scale. I call it a thimble scale, or sometimes it's called a vernier scale. So all we need is reading the last demarcation closest to the thimble scale here. And if you look at it on the main scale, it is the one of 0.5, because this is 0, then this is 0.5 down here. That is, now we write 0.5 here, plus then we look at the value of the mark that is coincident to this horizontal line of the main scale. So this value is 47. So we get 47 divided by 100, then plus the 0.5. So the answer will be 0.97, I guess. Yeah, millimeters. That is the diameter. Just imagine you are using geometer rule to determine 0.9 what? 9997 millimeters. It's weird. So that is it. These are just some examples you guys can practice on. You can pause the video and practice on how to read the scales of this is a micrometer screw gauge scale, still this is a micrometer screw gauge scale, this is a vernier caliper scale. You can also read this one. This is still a micrometer screw gauge, though this one is now given here. So you try these ones. You can pause the video a bit. We have absolute and percentage uncertainty. Like remember, we defined uncertainty as it can be a range of values within which a measured value lies, or it can be the equivalence of the smallest measurement of an instrument. Like a meter rule, the uncertainty of a meter rule is 1 millimeter. That is the smallest value a meter rule can give. For a vernier caliper, it is 0.1 millimeters. That is the smallest value a vernier caliper can give. A micrometer screw gauge, it is 0.01 millimeter. That's the smallest value a vernier caliper can give. So they are all written. We have all these values written, like for a meter rule, a vernier caliper, and a micrometer screw gauge. Their measurements with their own uncertainties. So like that. So the uncertainty for a meter rule is 1. The uncertainty for a vernier caliper is 0.1. The uncertainty for micrometer screw gauge is 0.01. Then these are measured values. Also, we need to understand that the number of decimal places of our uncertainties, they actually you first check the number of dp's for these uncertainties is the same as the number of dp's in the measured values. Like 1 millimeter written to 0 dp, obviously we have 12. 0.1 millimeter, we have 12.3 to 11 dp. So like that, we have 12.34 because we are seeing our uncertainty written to 2 dp's. Another thing about uncertainty, if you look at it, uncertainty is written to one significant figure, like that, just one significant figure. So meaning, if you see 12 plus or minus 1 millimeter, it means it is the measured value is 12 millimeters plus or minus 1 millimeter. That's the uncertainty, meaning the 12 millimeters, that's the correct value, the expected value, the actual value, but it is lying between 11 and 13. So you apply now to vernier caliper and micrometer screw gauge. That's the same thing. So we also look at this example here. Look at this example here. We have a measurement of 46.0 plus or minus 0.5 centimeters. The 46.0 is the most likely value to be measured, but it is lying between 45.5 and 46.5 centimeters. So this is a range within which the value lies. I'm sorry for that. This is a range of values that is between, okay, from between and from 45.5 to 46.5, like that. That is if you subtract the 0.5 from 46.0, you get 45.5. When you add 0.5 to 46.0, you get 46.5. So that's it. The 0.5 plus or minus 0.5, that's the absolute value, obviously. What about getting the percentage uncertainty? you basically get absolute uncertainty divided by the measured value, the most likely value, times 100%. So different instruments have different units. Different instruments have different uncertainties. So like an ammeter has uncertainty of plus or minus 0.1 amperes. So like that. So like I told you, the uncertainty in a measurement should be stated to one significant figure: 1, 0.01, 0.5, 0.00005, to one significant figure like this. And the value for the quantity should be stated to the same number of dp's, decimal places, as the uncertainty. Like if we have like the uncertainty for time is 0. plus or minus 0.1 seconds. So obviously the value, the quantity for time, the value for the quantity of, like the value for time from a stopwatch should be recorded to 1 dp, like that. That is, like for example, 5.8. Yeah, like that. Not 5.80, 5.81. No, it's 5.8. So like that. I think that is it about uncertainty. That's the one we need to know about uncertainty. Yeah, so that's the one that is examinable, that we need to know exactly. So thank you for your kind attention. We meet in the next lecture.